For this one we need a line for x, a line for 1 minus x, and a line for x plus 7, as well as a line for the overall product of all of those factors. So to begin with, when x is equal to negative 7, we have a 0 for this. This binomial is equal to 0 when x equals negative 7. When x equals 0, this one is 0, and when x equals 1, then 1 minus x is 0 when x is equal to 1. So, when x is 0, x is 0. And if x is bigger than 0, then x is bigger than 0. If x is less than 0, then x is less than 0. So it's negative. 1 minus x is equal to 0 when x equals 1. And notice that when x is bigger than 1, like 2, 1 minus 2 is negative. So it's negative to the right, and it's positive to the left. When there's a negative in front of the x term, then the negatives and positives are switched from their usual. Okay, x plus 7 is 0 when x is equal to negative 7, and it's positive if x is bigger than negative 7, and negative if x is less than negative 7. So now for the product line, we have a negative times a positive times a negative. That's a positive. Anything times 0 is 0. A negative times a positive is a negative. 0 times anything is 0. Positive times a positive is a positive. Anything times 0 is 0. And a positive times a positive is a negative. That last line tells us everything we need to know. And what we're looking for is, where is this product negative or 0? So where are the negatives or the zeros? So here's negative 7, here's 0, and here's 1. We'll put little circles around each of those, points on the number line. The negatives lie between negative 7 and 0. Everything in here, so that's part of the solution set. And everything to the right of 1. So everything out here also gets shaded as part of the solution set. Also, we include all the zeros because it includes that. So shade in each of these zeros as well, including this point, or including this point. And we're including this point, part of the solution set. And so, that's the graph of the solution set. Now this is negative infinity at the end of the line to the left and positive infinity at the end of the line to the right. So in interval notation we could express this as the interval from negative 7 to 0, including both of those endpoints, union with the interval going from 1 to infinity. In set builder notation, we can express this as the set of all x such that x is between negative 7 and 0, or x is bigger than or equal to 1. So there we have three ways of expressing the solution set to this third degree polynomial inequality, a cubic polynomial inequality.